Oh, you can cut them.
Oh, yeah, that's right.
We should lower the lights.
I don't know how to do that.
Woo, here we go. Well, I guess you're up first. I can
Relax. Yeah, I'm so tired. I'm waiting for some kind of like signal or something.
go for it, man.
Start. Hello. I don't think this is on actually. Can anyone hear me? Samara, turn my mic up. All right. Hello, everyone. Welcome. We're about to get started here. It's like quarter after. We've given everyone enough time, I think. Welcome to Facebook. I'm Tom Okino. This is Makinde Adeagbo. We're going to talk about some front-end stuff at Facebook. First, I'd like to thank everyone for coming out. I heard we're streaming this live on the internet, which is crazy, at facebook.com/Tech Talks. Is that it? Great. So I don't know why you guys would want to know that, because you're here. But somebody else might want to know it. So we're streaming it live. So again, welcome to Facebook. We're going to talk about some front-end strategies. I don't know why we really called it front-end strategies, but we're going to talk about some front-end stuff at Facebook. First, I want to give you guys a little history about things. So there were various articles written, and we've been in various books historically, because Facebook has been seen as a very bloated, slow site. I don't know if anyone's read any of these articles. Steve Souders likes to, use us as examples in his books of what not to do. Well, Makinde and I are here to say that the age of that is over, because we mean business nowadays. But I want to tell you a little about the history and how we got to where we are. So first of all, we just got to a point where we had way too much JavaScript. We were basically using JavaScript to do every single interaction that the user would have on the page. Anything the user wants to do, we're going to write some amount of JavaScript for it. Whether it's a little bit or a lot, we're just going to write JS to do every interaction. So what does this mean? If we have a lot of JavaScript and we have it in the head of the document, everybody knows what that means. The page is going to feel slow. Rendering is going to be terribly slow. And generally, users are just going to be unhappy because the site is going to feel very slow. At one point, we had like a meg of JavaScript in the head of our document. A megabyte of JavaScript. So how did we let this happen, first of all? First, we need to figure out, how did we get to a megabyte of JavaScript? Because this doesn't happen overnight. Well, basically, we made it very easy to write JavaScript. We made it so that you could compose a JavaScript file, and one line of PHP will make that JavaScript get spit out onto the page. We made it too easy to write JavaScript because everybody and their mother wanted to do it. Everybody wanted to write JavaScript. And again, this was like a compounding effect. It was basically, it wasn't one engineer writing a megabyte of JavaScript. It was 300 engineers, or less at the time, but writing 500 bytes a piece. And that just adds up and adds up. So how can we fix this? Well, the first thing we need to do is we just need to delete as much crap as possible. We just need to get rid of as much of it as we can. Makinde is going to talk a little bit about how we actually did that. But I want to talk about two systems that that were created to kind of aid in making this better and getting rid of this megabyte of JavaScript. We want to be able to lazy load things, so we have a system called Bootloader that allows us to do that. And Makinde is also going to talk about moving our JavaScript to the bottom of the page, which will not block rendering. So that's pretty good. So I'm going to talk a little bit about resources and how we're going to manage these resources going forward, because a megabyte of JavaScript is just way too much. So the first system I'm going to talk about is called Haste. Haste is our resource packaging and dependency management. So basically what this allows us to do is, from any JavaScript or CSS file, we can require any other JavaScript or CSS file. And this is pretty nice. This is a Haste block. This is what they look like typically. You require as many things as you need, and then you can provide a single thing that your file is intended to do. The way that this is integrated into the stack and into our PHP code base, we have a pretty big PHP code base, is through a function called require static. And basically what this does is, those unique identifiers that we talked about you can pass a single one of them to require static, and that unique identifier and all of its dependencies will then be pulled in on page load. So this makes it really, really easy and really simple to rapidly develop features, because you just make your JavaScript file, you run this little script we have called analyze resources, and it builds up all your packages for you, and then you just refresh the page and your stuff is there. So it's pretty nice. It's pretty convenient. So why did we build a system like this? So we built it for a few reasons. First of all, agility. We want it to be as simple as creating the file and requiring it, and then your JavaScript is just there. But also for simplicity. So we don't want to worry about file paths. We don't want to worry about where our CDNs are. We don't want to worry about anything. We just want to say, I need that resource, so give me that resource in this file. All of you are probably familiar with other systems for doing this. I think that Haste is, I've used quite a few of those systems, and I think that Haste is pretty superior. So I'm actually trying to get us to clean that up and open source it. I know David would probably be excited about that, because Haste is just a really great system for this. We built this for performance as well, obviously. We want to do lazy loading as much as possible. We don't want to have that big ball of stuff at the head of every document. One thing I forgot to mention is we want to make as much of this discussion as possible, so there's going to be plenty of time at the end for us to just talk about anything you want to talk about. So if you have questions, if you want to ask, you can just ask, but if you want to wait till the end too, we're going to have plenty of time for discussion. So yeah, these packages that we construct are pretty nice. On the home page, if we have some resource that's being required on the home page and on the profile, that resource might be in a shared package on both of those pages. So we try to kind of emphasize cache hits and stuff like that. And it ends up working out pretty well. Turns out this system works really well with our lazy loading system, which is called Bootloader. And what Bootloader is it's basically the system that you've seen plenty of times before. It's a dynamic script injection, lazy loading system. The way that it works is basically you call bootloader.loadComponents, and you pass it one of these unique Haste identifiers. And this Haste identifier, we use these everywhere. Everybody's familiar with them at Facebook, all of our engineers. And they become kind of universal. So here you see that I'm loading the component dialog. And then the second argument to this function is a callback. The callback function we want to be invoked when that resource is available. So this is really nice. This allows us to take as much of that JavaScript that we had in the head of the document and remove it from there and load it on demand. So the user clicks a link and we can load whatever JavaScript's needed for the feature that they're about to use. One example where we use this is in tagging of photos. Most times people visit photo.php, our photo viewing page. They're just going to be looking at and consuming, but sometimes they want to tag a photo. There's no reason that everybody should pay the cost for all of the JavaScript that's required for tagging a photo. So what we do is when you click that link, we load all the components necessary, and then we initialize all that stuff and tell the user, hey, it's ready to tag now. So that's one example of where we use this. But we basically use it all over the site. This works with Haste, so you can suggest a file that your component that you've built might need if the user does some interaction. And we have the @suggest tag, and that works just like @requires and @provides. And @suggest basically says, hey, I might need this thing, so get it ready, but don't necessarily download it right away. We also have, on the PHP side of things, we have a function called bootload enable, which allows us to do essentially the exact same thing from the PHP side. Bootload enable is pretty nice as well because, well, both of these tags are pretty nice as well, because if the user's browser is idle, so say we finish loading the page, and we think that there's something that is pretty common that they're probably going to need to do, what the system will do is it'll automatically in the background start downloading those things so that if the user does perform that interaction, like they do click that tag button, well, we'll have the resources ready so their callback can be executed immediately. So Bootloader is a pretty nice system in that sense. Basically, why did we build it? For obvious reasons. I don't know why I put the picture of the boot, but why not? Why did we build it? We built it for performance and to reduce waste. So the next system we're going to talk about, Mackinday is actually going to talk about, and it's called Primer. Many of you have heard about this. Who knows what Primer is? Raise your hand for me real quick. A few of you? Okay. Some of you actually all work at Facebook, probably. That's fine. All right, good. I hope you know what Primer is if you work at Facebook. others of you, we've spoken about this at a few different places, but Primer was like, we came in with Primer, and Mackinday just changed the way that we write front-end code with this stuff. So it's pretty good. So I'm going to pass it off to him. Here.
Cool. Thanks, Tom. Cool. So this is Tom's slide, not mine.
I was supposed to switch to that.
Right. Cool. So my name is Mackinday. I've been at Facebook a little while now, and I've worked on various aspects of our front end. Last year, it was front end performance was what I was focused on. So this is a waterfall from about 10 months ago of, I think, the Green Day profile page. There are lots of things going on here. That's one problem. Notably, you'll see here we have a bunch of CSS being downloaded. This is what the browser is going through as it's trying to load the page. So here it's downloading CSS, which is good. One problem here, though, is that the CSS is all being downloaded at the bottom. This is after several images have come down. This is after several JavaScript files have come down. And if you think about it, the browser really needs CSS to show you the page, right? It's not going to render a page and then, 5 seconds later download the CSS. This is the first thing it needs. So what's above it? Well, there's some images which might be acceptable, but the real problem is we have tons of JavaScript being downloaded above these CSS files. And in theory, the JavaScript isn't really needed to show the page to the user, right? The Facebook model is that we are rendering our pages on the server side in PHP, and the JavaScript is only going to add functionality. But the user should be able to still view everything and start consuming content without the JavaScript. So we have things kind of happening in the wrong order here. So the industry solution to this is put your JavaScript at the bottom of the page. Simple enough. So we did this. We called it Roadrunner. It made the site load faster. And you certainly saw content a lot faster. But there was a problem. So the page shows, maybe in, let's say, 1 second. But while the browser is downloading JavaScript in the background, nothing is actionable yet. You can click on stuff, but it'll throw a JavaScript error. We may have an inline handler or something that is calling to a function that's not there yet. So when the user clicks on it, they think the page works, but it's actually still broken. So we thought, actually, okay, this might be acceptable, but even turning this on for employees who are, on an extremely fast connection on very fast computers, every employee still complained about this because the delay was still too long. So we had to kind of go back to the drawing board. We'd really like to move all of our JavaScript to the bottom of the page, but we have this problem where our interactions don't work. So we set out on a goal to try to boil down the site's interactions into a small set of things that we could possibly wire up very quickly with very little JavaScript, so that we could put that JavaScript at the top of the page and have the page be functional without blocking it with all of our other libraries. So we looked at the site, and we basically came up with this, that just about everything breaks down into this flow. User clicks on something, we send an AJAX request, we get a response and shove a bunch of stuff in the DOM. It's pretty simple. And, we started with this hypothesis that this is what we do everywhere. And we started realizing more and more that just about everything fit this mold. Now, it's important to mention here that it's just about everything. It'd be great to have a solution that fit 100% of the cases. But here we're really looking for the 20% of code that can enable 80% of our interactions. Because we're looking for this to be the one blocking JS file at the top of the page. So we don't want it too large, but we want it to do just enough. So we called it Primer. It's our initial base code of JavaScript that enables us to do most of the interactions on the site. So what are these interactions? What are we doing all the time? So one example is a dialogue. We open dialogues very often on Facebook. You may or may not have seen this one. This one is actually linked to off of every page. There's a link in our footer that opens this language selector dialogue. And, okay, it looks simple enough, but you have to look at where we were coming from. In the old world, in Facebook's code base, to open that dialogue, you'd first have to have, in HTML, a link on the page. Usually the link didn't really go anywhere, but it had an ID so we could find it. And then in PHP, just after rendering the link, you would say, onload register, which in our code base means call this JavaScript when the page loads. And that onload register would call some JavaScript that you'd written. It was a bit lengthier. And that JavaScript would then find the element on the page, add a click listener to it, and then that click listener would then send an AJAX request and maybe read some data back from the response and set up this dialog. So to open the language selector dialog, we had all of this code, right? And like Tom mentioned, this code doesn't seem so bad on its own. And this is maybe an engineer writing 500 bytes of code. It's not, might say that's acceptable. But again, when you look at a large engineering team, if each engineer for their feature is adding 500 bytes of code every week, you quickly end up with a meg of JavaScript. So that wasn't really workable. So we went back to the drawing board. So we decided to start kind of at square one. What is the primary thing here? The primary thing here is the HTML and a way to find this element. So we decided to look at what was already in the HTML standards that we could use to mark these links. We have a set of links that needs to open dialogues. So we use the rel attribute. So here you see my link. It's linking directly to the endpoint that it'll get its data from. And we're using the rel attribute to mark it as, hey, this link needs to open a dialog. So then we started work on Primer itself. The JS that we can put at the top of the page that will be able to listen for clicks on links that look like this and send an AJAX request to the server. Turns out you actually don't need very much. When you click on that link, that event will bubble up to the root of the document where we can conveniently listen for events. We don't really need, at this point, that much special library code. You'll notice here we're doing kind of our own browser workarounds ourselves that you normally leave to a library. But we don't even want to have to load a library at this point. We just want the simplest thing possible. So we're capturing all clicks on the page. We're looking to see if it's an anchor tag. If so, does it have a rel attribute? If so, is it a dialog? Cool. Then, like Tom said, we're able to bootload the dialog class and open up that dialog. So that actually means that we don't need the dialog class to exist yet when the user clicks on the link. This is the only JS that we need, which is actually pretty cool. So you may notice in the earlier example that I showed about kind of the old way of doing it, we had a lot of code in our JavaScript to set up this dialog. So we had a dialog class in JavaScript that enabled you to build dialogues. So instead, in the Primer world, what we did is we pushed that back to PHP. So in your endpoint, you can now specify that I'm sending back a dialog to the client, and all of the functions that exist in the JavaScript class of dialog exist on the PHP class of dialog. So you are able to configure what the user will see from the server. And this actually turns out to be a pretty powerful concept, because what it ends up meaning is that as long as you can get a request to the server, you can change the page. You can open a dialog. So these are kind of the three parts that we needed. So to compare the old and new, now, on the left you'll see what all the code that we needed in the old way. We needed some markup, we needed some PHP to set up some JavaScript. We also needed some JavaScript. In the new way, we really only need the markup. And there's a fixed amount of JS code that is Primer that sits at the top of the page that is going to wire up all of these dialogues. So as we continue to add dialogues to the page, links that open dialogues, all we're adding is markup. We're not adding any JavaScript whatsoever. So the empty space on the right, that's just pure win. That's that's just saved time for the user. Save time downloading JS, save time evaluating JS. It's just awesome, right? So again, I mentioned we were looking for the 80-20 solution. And this actually ends up being a surprising amount. In fact, as we were putting together these slides earlier, Tom surprised me with how much this is. We have over 500 calls to rel, or 500 links that are saying rel equals dialog in our code base. 580, which is pretty impressive. It actually ends up being more than half of the dynamic interactions that we wire up with JavaScript are just opening dialogues. So this on its own is probably 50% of our interactions are just opening these dialogues. So that's great, but we're looking for an 80% solution, right? We're not there yet. So what are some other things that we do on the site? Let's say this older post link at the bottom here, right? You guys may have used it. You scroll to the bottom. You click this link. an AJAX request goes to our servers, it comes back with markup, and you insert some more stories into the DOM. Well, that sounds like exactly the pattern that we are following anyway. But this doesn't open a dialog. It's a bit different. So let's add a new rel attribute. Rel equals async. This one is a bit simpler than the dialog one. All it does is send an AJAX request. It's pretty simple. But we're going to need some different things. So before we'd recreated our dialog class that existed in JavaScript, we'd recreated that in PHP land. But this is not so clear. Sometimes you might want to add content to the DOM. Sometimes you might want to remove content. Sometimes you might want to replace nodes. But it actually seems pretty easy as well. We can just recreate our DOM library that we have in JavaScript in PHP. So in an async response object, you can just call a method that is set content or append content or replace content, all methods that we have in JavaScript. You can call those from PHP, pass it a selector and some markup, and when that response reaches the client, it'll execute it. And you can replace whatever you want in the page. So again, this is really powerful because as long as you can get an AJAX request to our server can do whatever it wants to the page without adding any new JavaScript that blocked that page loading. So you might be asking on this page again, that older post link. Now, if you wire it up just with JavaScript, you've sort of won. You know, most users will be happy, but those users without JavaScript will be sorely disappointed, right? Because they're going to click that link and nothing's going to happen, and it looks like it's progressive enhancement, but it's not, and you're going to end up failing. So in this case, the endpoint that will give us more markup to put in the DOM is very different than the full page load that needs to happen if you don't have JavaScript. So in a way, we almost need to specify two endpoints, two links for this particular anchor tag on the page. So we needed something other than href. We needed another place to put this link. And we searched the specs. We were looking for some great place to put this second URL, and we just couldn't find anything. So we just gave up and came up with the Ajaxify attribute. Sounds kind of weird, but it gets the job done. The nice thing is, it's a weird enough name that if we wanted to change it, we could grep for it and change it later. And that time hasn't come around yet, so we're living with it. So it's actually pretty nice. So let's say we needed a link that if the user did not have JavaScript, or if they wanted to right-click and open in a new tab, they could right-click on it and they would go to ring.php. If they just clicked on it and they did have JavaScript, an AJAX request would be fired off to ajax/ring.php. So now we actually have a fairly nice progressive enhancement approach to this, where the non-JavaScript version works, and if JavaScript is there, we can very easily tie on and send the request that we need to send. So this is pretty solid. This is probably maybe another 20%. So we're up to 70% of our interactions. You might be thinking that there are still more, and there are. When we were building this, people really pushed back on us. It's like, okay, this primer stuff's kind of cool. You did a lot of the simple things, you can show more content. Yeah, that's easy. But we got this composer here, this thing in the middle, which allows you to update statuses, upload photos. The thing at the top is allowing you to add friends, kind of remove pending friend requests of sorts. And this thing at the bottom, you can add comments, you can like things. It's pretty intense. You can delete comments. You can see more comments. There's no way this stuff is going to work. So we got to thinking. We're like, they might be right. We can't really use links for all this stuff. Stuff's really complicated. We want to use progressive enhancement. Maybe there's some HTML5 or HTML7 element that we can use. And we actually found something that actually works pretty well. And they're called forms. So these things are pretty awesome. They actually store data for you in input elements, and when you click a button, it will send the request to the server, which is basically exactly what we need. It's pretty awesome. These had become an endangered species at Facebook. If you're writing a site with tons and tons of JavaScript, it's very easy to forget about actual forms. But they're making a comeback now. So this actually ended up being one of the simpler cases. So we took regular forms and we added an Ajaxify attribute. When that attribute is there, Primer captures the onSubmit event for the form, serializes that form, and sends it as an AJAX request. And again, once we have an AJAX request to our server, we can do whatever we want to the page. Right? So this actually ends up being able to power a whole new class of things. And it's actually not that much code. It's very similar to the click tracking that we were doing on links, except now we're capturing the onSubmit event. If we find that the form has an AJAXify attribute, all we have to do is return false, which will kill the form submission, and send an AJAX request. So it fits very well into the pattern. So looking at, this is our unified feedback interface, this blue comment box that you see everywhere on the site. And we just went to town on this thing. So we're like, okay, let's get started. This thing, that's easy. We got to make that a form. Simple enough. This delete dialog, or delete link, all that does is open a confirmation dialog. So that's pretty easy as well. This view more comments link is a rel equals async that will shove more comments into the DOM. This one was a bit tricky at first, but turns out the solution's pretty easy. This comment link, it's a label tag. It used to be a lot of JS to focus this box and do all sorts of other things. Turns out label tags work and have worked for a long time. So a lot of this is kind of just getting back to basics. And this like link was actually a bit tricky. The key thing to realize is that it doesn't have to be a link. We actually use the button tag here and style it as a link. So there are actually a lot of these kind of hidden around the site. A lot of X's you will find on the site are actually button tags, styled to look as links. Cool. So this is one example, of this form. But you're probably saying, surely this didn't look that complicated. How big of an impact could this have been? Well, we started to delete a lot of JavaScript. And this video here is the diff that removes JavaScript from that unified feedback interface. And it keeps going. And we celebrated these diffs. They were pretty awesome. These started flying around left and right last year.
You should let it run, because it's like a few more minutes.
It goes pretty long. Our VP of engineering made this video. Because he got excited that we were removing so much code. So oddly enough, what Primer sort of ends up being is JavaScript that lets you remove lots of JavaScript. And it's just, again, bucketing and simplifying our interactions. And I don't think that code was that well commented, so this is mostly code.
Yeah, there were no comments in that code.
Yeah, so it's pretty substantial. So again, if we were to visit our waterfall graph that we started with, so we started with this problem of JavaScript blocking our CSS. So after Primer, we were able to get down to just one JavaScript file in the head of our document, and all CSS was loaded sequentially. And then at the very bottom of this chart, what you don't see is that after the page loads, we wait 50 milliseconds and then start downloading our JavaScript. In theory, if everything is built on top of Primer, we don't even care when that JavaScript comes down. Primer is completely self-sufficient in that it will bootload whatever JavaScript it needs when it needs it and take care of the interaction. And will kind of show the user, hey, I'm doing something, hold on. So this was a pretty significant step forward for us. But how do we make sure we don't get back to where we were, right? We made it very easy to write JavaScript before. Everybody in the company, it was kind of expected that every engineer knows how to write JavaScript. And while Primer started small, you saw just about all of the code in that file. If every engineer came by and said, oh yeah, I have my one case that it doesn't handle, I need to add some code, we'd basically be back to where we started, which is why defense wins championships. It's critical in our company and in general to make sure that you guard your abstractions. You cannot make it too easy to let people add things willy-nilly to core pieces of infrastructure. And that's what we've actually done a pretty good job with. It's surprising. Weeks after adding the Primer file, I would come to Tom and be like, hey, Tom, I had this great idea. We gotta support animations and spinning 3D effects in Primer. And it was critical for Tom to say, hell no. And the same thing, then Tom would come to me the next week, hey, I got this great new use case. And I just had to say no. right? There are lots of things that Primer won't do, but it will do a lot, and it's important to keep it as small as possible because it is blocking the user viewing the page. So this is up on GitHub. There's actually, it's good and bad. It's up there, but there's not that much of it, and I try to keep it that way. So you can check it out. We'll put this link on the events page if you want to check it out, or you can actually just look at our JavaScript that we send down on the page. So yeah, we'll update this, but yeah, you can totally check it out there. There are a few Facebook-specific things like Bootloader in there, but those are actually pretty easy to substitute in your own other, asynchronous loading technologies. So yeah, I'll let Tom wrap it up.
Before we started talking, he looks at this slide and he goes, "What are we going to say when we get to this one?" I'm like, "You can just hand me the mic and we'll figure something out." I didn't figure anything out yet. That was basically, what we wanted to talk about was, a little of how we changed our mentality. We changed our model from, let's write JavaScript for every little feature to let's write as little JavaScript as we can. And still to this day, there's people trying to add lots of JavaScript to do other stuff, and we just have to fight back. We had a slide that said next steps. I'll talk for a minute here about what our next steps are on this. By now, everybody knows the power of event delegation, and that's basically what Primer is it's just letting the events bubble to the top of the document. We kind of want to, in the future, use that as much as possible to our advantage to allow us to not need one-off event handlers. We still have this function called event.listen called all over our code base, and basically it just attaches a single listener to a single node. And what we're moving towards is a model where you annotate your markup in such a way that, for example, I would give all of the like links on a page a special sort of annotation, and then we would know that when that thing is clicked, we can perform some action that maybe is more specific than Primer. That's kind of a bad example because Primer handles that case well, but there are tons of examples where Primer just won't handle it. But we still want to use the benefits of event delegation. So you'll hear more about Javelin very soon. But that's our open source library. That's going to be the next iteration of our current library. So that was. You want to talk more?
Yeah. No. I was just going to say, Tom and I totally wanted to open this up for kind of open discussion. If you guys have questions about what we're working on, the stuff we talked about, front-end stuff that's going on at Facebook, we by all means want to take and talk about any questions that you guys have.
Yeah, I'm going to leave this slide up, but let's just talk about stuff.
Yeah.
What's up?
So why the Ajaxify part of the link, and not why not just another space rel? Why not just another space?
Put the URL in the rel directly?
No.
Oh.
Just
repeat the question.
Did you know how you could? So in CSS, you can have different selectors based on there's a space in between the. You know how in CSS you can have different selectors if you put a space in between them in the class tag?
So the question is, why didn't we just use the rel attribute to annotate where the AJAX request should be sent to?
Yeah.
So it's funny that you asked that. I actually, 3 hours ago, I asked Mac and I said, why didn't we just store the rel, or store whatever href we had in Ajaxify and just check for the existence of that attribute? And he's like, yeah, that's a good point. We should just use the single attribute to, denote both that we need to send an AJAX request and the type of AJAX request.
Yeah.
And the reason we haven't done it is because there's 600 callers and we don't want to change them yet. But yeah, there really was no reason. We were just kind of powering through this stuff, and as we were making it, it was very easy to understand that the relation of this link is I need to open a dialog. The relation of this link is I need to send an AJAX request async. So there's really no reason.
So you guys are not standard junkies.
Well,
to an extent.
Yeah, I'm not sure. If you think about the purpose of the rel attribute, just putting that this is a rel equals dialog or rel equals async actually, to me, is closer to what the standard implies than storing arbitrary data. In theory, what we could do, and the right way to do it in the HTML5 world, would be to use a data attribute for the extra data that we want to store. But our doc type's not HTML5, and I'm not sure how soon it will be.
We do support standards, but we support them to the extent that it's realistic. Because first and foremost, we're realists, right? And like this got the job done, so that's cool.
How do you version these modules?
How do we? So
You're talking about
blame the file.
JavaScript modules,
Yeah.
in kind of the Haste world.
Yep.
So the short answer is we don't. Roughly, we version them by subversion version. So kind of, we know for a given package, the last revision that a file in that package was modified. So we'll that's part of the URL for the resource. So if you check in a new version of foo.js, and that is in package A, the URL for package A will change automatically. So when you render a new page, it will request the new package.
I'll say a little more about that as well. Our packaging system is pretty intelligent. So if any file inside of the package changes, like Mackenday said, you'll get a new package the next time around. And so when I first heard about this, I was like, okay, we should probably stop changing certain files so our cache lasts longer, right? Because you don't want the user coming to the site with a cold cache every day. Turns out our site is very photo intensive, and browsers currently are pretty terrible at browser cache. They're just really not good at it. So we invalidate our caches basically every 3 to 4 hours at a minimum. So it's really not important for us week over week that we maintain certain files. And we actually experimented with I talked about those crazy algorithms. We experimented with some algorithms that attempted to package files that don't change as often. So Bootloader hasn't changed in a very long time. We have another snippet of JavaScript that lowers the domain for like iframe stuff, and that hasn't changed since it was checked in. But it turns out that our cache hit rate is so low that it doesn't even really matter. So essentially, we just generate a new package every time we push. Yeah, and that's basically how it works. Yeah.
How do you guys separate behavior and markup?
So a few ways. So what we try to do is, again, we understand that we have full control over our markup. So we try to annotate it a little bit. The stuff that I started talking about at the end there, like what's next, this is basically the entire premise for how this new JS library Javelin works. You annotate your markup with the type of behavior that it needs. So that's not really separating, that's kind of coupling it. How do we separate behavior and markup?
Yeah.
How do you separate behavior and markup?
Well, that's why I'm asking is it seems that some people have tried to come up with their own solutions, sort of trying to do like an MVC type pattern in JavaScript and so on. But I'm not really familiar with any preferred way of doing it at this point.
I mean, it's JavaScript, right? Do we need MVC? Maybe. I don't know.
So, I mean, the model we're predominantly moving from here is we used to kind of write these, like in the example I showed, these JavaScript controllers, which were, trying to break that stuff out a little bit. So you have this elaborate controller that's storing all of its state itself, which worked great coming from the world we were in 2 or 3 years ago, where, there was no real separation. It was kind of all muddled together. But again, the problem we ran into is just kind of having to set up these controllers, like for the UFI, each like leak in there having its own controller and being able to do things just ended up being too much overhead for us. So actually what the world we're kind of moving to is moving a lot of this. The markup only knows that it needs to basically where to get more instructions. So it knows where to send a request to. And the server actually ends up being the thing that knows the logic about what to replace in the DOM. Now, that seems a bit weird in that it seems odd to have your PHP code knowing how to update the state of the client. But actually, if you try to look at it in a very simple way, it ends up being pretty easy to stay away from thorny issues. For instance, if you touch one part of the UFI, oftentimes the server will just be like, oh, I don't want to get into remembering your state or anything. I'm just going to replace the whole thing. Mm-hmm. Or things like if you add a comment, we don't necessarily want to have a logic that resets the comment box to like clear out the comment that you typed and collapse it again. The server just sends down a brand new one and says, I don't care what you did before. I'm just going to replace this whole box. So it actually ends up being pretty simple. Usually an endpoint will replace 1 or 2 divs. If you're doing much more than that, oftentimes it's simpler just to zoom out a level and replace a bigger div.
All right, thanks.
Yeah, do you guys do any test driving or any unit or integration testing at all?
Yeah, so we have tests kind of at many levels of the stack. We do have JavaScript unit tests. We kind of just moved from QUnit to JS spec. But we also do kind of high-level integration testing with Selenium. Yeah, and Water. Water more recently. Sorry, I'm behind.
Sorry, do you plan on moving Primer to OnConnect or OpenGraph so that others can bring Facebook functionality onto custom sites?
Oh, interesting. You mean in place of Facebook Connect?
Yes. So don't have to load all the JavaScript.
Oh, interesting. I had not thought much about that.
We're thinking about it now.
We have worked a little bit with the platform team to try to get a lot of our widgets to use Primer because they're kind of a great use case for it. They oftentimes have one or two interactions that are usually completely doable with Primer. So we're moving in that direction, and we're trying to make those lighter weight.
That'd be awesome.
Yeah, yeah. No, there are some complicated issues with Connect, but we're certainly like really focused on not just site performance, but also platform performance. Yeah.
Hello. Yeah, I have a question. On Facebook, when you do like load all their posts, on the Ajax call, do you guys generate the HTML on the server side, or you guys return a JSON response and process it?
Yeah, so we used to operate on this model of generating JSON responses with basically just the data you needed, and some JavaScript class would figure out what to do and build markup around it. The nice thing about this is that it actually forces all of our rendering to one place, which is the server. We don't think of the extra markup being sent over the wire as necessarily a hurdle. In fact, it's nice that you didn't have to write anything in JS, so there was nothing blocking the page. And now that you've asked for more data, we're willing to suffer, an extra millisecond or two for the added convenience of having all of that rendering localized to one place.
And another thing to keep in mind is that while people will say that the payloads are a lot heavier, especially with HTML markup and the things like the stream stories, a lot like gzip takes care of a lot of that for us. We have a lot of repetitive over and over. You have stream stories have the same markup over and over. So gzip kind of makes our payloads a lot smaller. And our bottleneck is it really isn't bandwidth in terms of those responses. It's the latency to get it and the server generation time. So while we could write some JS that would handle a JSON response and generate markup, the duplicate code that we would need to have is like not worth it for us. Yeah.
Right. That reminds me of an interesting point, which is kind of another reason that we got to where we got was because the server was seen as slow and our page loads were slow. So we wrote more JavaScript to avoid page loads, which of course made the page load slower. So one big thing that we've been trying to push for is to kind of evangelize that the site is fast. A hit to the server is not necessarily slow. So some of the interactions, people will say, oh, you moved it to Primer. We used to be able to do all of this fancy stuff in JavaScript to make the interaction instant. The view more comments is actually a really good example. One guy, Adam Hupp, worked really hard on that to actually make that interaction blazing fast. So while that does a round trip to the server, a lot of times you won't even notice. It appears almost as instant for you. So a large part of this is just believing that, or making a request to the server, having the server get data, render it, and send it back, believing that that is fast, and pushing forward in that direction. Yeah.
Hi. What were your favorite tools that you used to measure performance during this development process?
We have quite a few internal tools for measuring stuff. We have one called ODS, and basically it gives us very, very detailed graphs on any metric you could imagine. So it's really nice to be able to see over time how our JavaScript bytes and how our time to interact, as we call it, is doing. But those are, I think, our best tools. I wanted to include a graph, and I forgot about it. Nan. I wanted to include a graph that shows how our JS bytes have been trending over time, because this wasn't like a one-time thing. We've been steadily decreasing the amount of JS on our page for about 18 months, I'd say now, and it hasn't, like, other than a few blips on the trend, it's way down. And so these ODS tools and stuff like that, they let us see very fine-grained as well as zoomed-out big-picture stuff. Some other tools we use is PageProf. We don't use PageProf.
Yeah, it's a mix between general tools that everybody uses in their browsers. A lot of these tools were just coming out. Google's PageSpeed was of some use. I forget the name of it. There's an IE extension that will actually show you in a really detailed manner exactly what the browser is doing as it's downloading resources and processing them, and which function calls are taking a long time.
Anyone know what that thing's called? It's really good.
Dynatrace. There we go, for the win. And we found out about that kind of halfway through our perf initiative last year. Another interesting tool that we have is called Calorie, and on about one out of every 100,000 or 500,000 page views, it'll actually record almost every browser event that happens. Like, okay, we finished downloading this JS, we finished downloading our CSS, and we'll actually record and aggregate that data back so we can actually visualize it in our ODS graphing tool. So we can actually go and see by country or by browser kind of which parts of the loading time are taking the longest, which countries have the highest latency, and kind of how that affects our page load times. If this is something that's consistent across all pages, or are certain pages slower, which is actually a pretty interesting thing to look at. So our metric last year, we were operating on the 75th percentile for page loads, and you actually might think on an initial glance at it, okay, maybe that is like the home page is kind of slow, and our canvas page might be kind of slow. So maybe those are the ones that are taking up all the those are all the page loads that are in the slowest 25%, but it actually ends up being pretty even, which suggests that latency is one of the killer things, because server generation time does fluctuate per page, but the fact that the overall end time is basically flat across all of the pages, or they're equally represented in both sides of our cutoff, suggests that users' browsers, like for this user, the entire site is slow. Or in this country, the entire site is slow.
So this is so cool. As an app developer, I couldn't wait to try it out in my iframe-based app, Facebook app. And do you envision any problem with namespace conflict or any other issues? Has any app developer tried out yet?
Not that I know of. In fact, so I mentioned that we had Roadrunner, which takes our JavaScript and puts it at the bottom of the page. The page we have the hardest time doing that on is canvas.php, because to move our JavaScript to the bottom of the page required us as an engineering team to rethink how we approached writing our site, and to do things like use Primer and know that the page might be shown before the JavaScript is ready. We have a much harder time telling that to every developer.
Third-party developers.
Right, third-party developers. So I think that's actually one of the things we'd love to do, because it's kind of a win-win. If we can move our JavaScript to the bottom of the page for Canvas pages will show faster, but the challenge is communicating and getting developers to adjust accordingly is kind of tough.
I'm not sure what you mean about namespace conflicts. Primer doesn't actually include anything in the global namespace, except it's just a closure, right?
Yeah.
It's just a single function. But in order to use it, there's other things that it's relying on, like our bootloader component. But certainly you could use the technique, and that's kind of why we show how simple the code is. Use that technique with whatever library that you use. We're going to try and backport it to this. We're going to have a version of it that works in our new JS library, Javelin, just because we have so many call sites that we want to be able to support those things as well as new stuff going forward. So yeah, it's really about the technique, not really about the actual code. So yeah, in your iframe, you should just do whatever you want. Use whatever library you want.
Yeah, I think the app loading user experience also very important.
Yeah.
And that will improve the overall user experience overall. Okay.
So this comes from somebody on the live stream who's definitely read your blog posts, and they're wondering how Haste and Primer work inside of BigPipe.
Yeah, so that's great.
They're throwing the big guns at us.
Abstractions on abstractions, we call that. So I actually had a slide. I actually had a slide that was called Other Abstractions because recently at TXJS I spoke about 10 abstractions that we have here at Facebook. Why don't I just talk about one of them called BigPipe really quick, and then we can talk about how they interact. So BigPipe is our solution for progressively rendering our pages. It's the logical evolution over a system we had called Early Flush. What Early Flush does is it allows us to flush the head of the document down to users' browsers before the page is necessarily generated. So you might go to the home page and we might not have any idea who your friends are yet, or what kind of content you need to see. But we can still send the head of the document down to your browser so that the browser can start downloading third-party JavaScript from our CDN and CSS from our CDN. So what BigPipe does is it tries to take that one step further and say, hey, we can render the head progressively. Why can't we render every single piece of the page progressively? So some of our back-end geniuses developed a system called pagelets. And what pagelets are is they are little pieces of the page. And if you look at the home page, you'll basically see a bunch of boxes. You'll see the publisher at the top and the events box on the right, your navigation on the left, and some requests and some other things. And each one of these pieces is its own little web page. And what BigPipe does is on the server is it takes each one of these things and it renders them independently. So it generates all of those pieces. There's a bunch of different modes that it has, but basically it renders them, it can generate them in parallel and then it can render them in parallel. And so what it does is as they're done being generated and rendered and we have the text, or that's basically just a string that we generate, right? We send that response down to the browser as soon as it's ready in the form of a script tag, which replaces pieces of a skeleton, the skeleton that was sent down at the very, very beginning. So the way that BigPipe works with Haste is basically exactly the same way that a regular page load would work with Haste. If you require any JavaScript, it makes sure that if it was required inside of your pagelet, when that pagelet is rendered, it will have all of the JavaScript that's needed for that pagelet rendered as well as script tags. It basically, everything is intended to be completely transparent to developers, to engineers at Facebook. Maybe it's opaque, actually. It's opaque. It's supposed to be completely opaque. I don't know why I said that. So we have a few other systems, and if there's questions about that, I'll talk about it as well. Thanks for catching my vocab. Yeah, it's supposed to be completely opaque. We're not supposed to, as engineers, know that BigPipe is there rendering the page. So the way that it works with Haste is exactly the same way as a normal page load works with Haste. And we also have a few other wonderful, crazy systems. Maybe we'll get some questions on the live stream about those as well. Yeah.
So how do you keep track of client-side state if that, for example, clicking the same button a second time creates a different action?
That's good. Yeah, that is true. The approach we took to that was kind of, again, what are the simplest things we can do to get a lot of the benefit? So if you use a form and it is Ajaxified, when Primer bootloads the code it will need to actually send that Ajax request, it will just disable every input in the form. And when the response comes back, it'll re-enable them.
So other than that, if you click the button again and you expect a different response, for example, clicking the more items in the stream, the first time give you a second page, the next time you click it, you get more news that are different.
Right. So this was actually only recently handled. I guess our approach to that was we'll deal with it when someone complains. Actually, we went pretty long without anyone complaining.
It's like 8 months. I think it was a long time.
So we kind of, again, went for the simplest solution. So when you click on a link, we add... Sorry, I guess I should explain a bit more. So when you click on a link and you send the Ajax request, our Ajax library has a method that allows you to set a status element, which is you pass in a DOM element saying, add a class to this DOM element so I can tell the user something's going on. So it'll show a spinner, right? So Primer automatically sets that status element as the element that was clicked on. So if you click on that element again, Primer will say, hey, this already has a status element class on it. I'm just going to stop. And again, you could make academic arguments against it, but it works. It's storing state in the DOM, which is suboptimal, but the fact that we're able to add, maybe 20 characters to Primer to fix the problem is actually, we're pretty happy with that.
Another thing we do commonly, since we're adding this JavaScript, or we're adding this CSS class name with JavaScript, sometimes what we'll do if it's kind of a bigger part of the UI is we will have in the DOM, we'll have an anchor and a span, and we will toggle the display of one based on whether it's saving or loading or not. So if you go to your edit profile and you say add another school, while it's fetching the other school, it swaps the anchor for a span that looks exactly the same. So there's some interactions where we need to do this type of styling, but again, most of them are one-offs, and Primer handles the 80% case pretty well.
Right. Also, if you click a link/button, as we found out today, it will actually change to dislike right away. And that dislike link looks like it works, or unlike. Sorry, we're not adding that. Oh, no. It will instantly switch to unlike, and that unlike link is already in the DOM. So we're using this kind of async saving class to make it appear that the interaction has happened instantaneously. And when the response comes back, it will replace that unlike link with a real unlike link that will work. So a lot of this is thinking of these, ways to take this strict set of tools you have and figure out how to build what you need to build. And you can actually get pretty far.
One more question from the stream.
Yeah.
The question is, what's next? Where are you guys going from here? That's actually from Shrep.
Uh-oh. You can take this one. I didn't know this was a one-on-one. So there are actually a lot of cool things that this opens the door for. Tom was mentioning kind of the Javelin framework, which is one thing that we want to move towards, which is basically a really tiny JavaScript framework that kind of takes this same approach of let's do as little as possible that enables us to get most of the things done. It's actually it's pretty tiny. I don't have the exact number on.
It's like 5K, and it's an entire library, and that's like compressed size. So
right.
If I think like a jQuery or MoTools is approximately like 22K, it's about a fourth the size, maybe a fifth the size, and that includes like a ton of features. It doesn't include animation because animation's clowny.
Right. So that was actually built for the Lite site, which lite.facebook.com, which I think launched last year and was recently taken offline. But it was a great proof of concept that we were able to build a fully functioning kind of version of Facebook on this lightweight framework. You can actually currently see it in action as well on the developer site. It's used there, which again is just these pages should just be fast. They should not be bottlenecked with tons of JavaScript. So they were able to just start from scratch and rewrite it on that site. We're also exploring using Javelin on mobile because it's lightweight enough that we can send it down to a lot of clients. For Primer specifically, we can actually start looking at problems in kind of a new light. One interesting kind of offshoot of this is using Primer to enable us to log things more easily. If you think about the way Primer is set up, you have these links, they have hrefs or ajaxify attributes. When someone clicks on a Primer link, it's extremely obvious what's going to happen. In the old world, there was some JavaScript listener that was listening to that thing that would go off into the Netherlands and do crazy things, right? It was very hard to track what was going to happen when any particular element was clicked on. But in the Primer world, that's actually really easy now. So we have another system called Eagle Eye that's basically trying to track client-side events and report back, what's going on. And it's actually very easy. It sets up a global listener just like Primer. That is basically like Primer, but instead of actually sending AJAX requests, it merely logs that, hey, the user is about to go to this page. Or, hey, the user clicked on a link that's going to load something from this AJAX endpoint. So by channeling everything through a very narrow space, we're able to observe things much more easily.
So we should probably, getting back to the what's actually next, we're going to continue on our trajectory of deleting as much JavaScript as possible. And we want to continue to make as much interactions as we want users to be able to, or engineers to be able to develop. We want them to be able to create those interactions without having to write a single new line of JavaScript. So we're going to keep doing that.
So can I ask that when you download a component like dialog, how much JavaScript you download? I mean, in terms of JavaScript, number of JavaScript file, to download a big chunk or bundle of dialog JavaScript, or several dependency you will include before you have that dialog ready? If you have multiple JavaScript file in a large application, how do you manage all the dependency? Because I saw that you have the syntax like require. What if a component that requires more than one dependency? How do you manage this thing? Do you pre-process your JavaScript code? How do you do that? Thanks.
So a couple things. First, I mentioned that Bootloader is a system for dynamically loading scripts. It's actually a system for dynamically loading and unloading scripts. So what happens is if something falls out of use, it's no longer being used, or you've switched to a different page or something like that, it unloads things that it's no longer using. And this is really interesting when it does it.
What do you mean by unloading? Because it's loading the memory, right?
It does it for both. But yeah. Yeah, so we have it. Let me answer your question first. So how does it manage this? You click a link to open a dialog and you end up downloading 16 megs of JavaScript, right? So it's not quite like that. The packages are built in such a way that dialog and all of its dependencies are guaranteed to be there before the callback is executed. So when you click that thing that is requiring a dialog, it's going through a map that it has, and we send this map down to the client side and saying, okay, I have all of these components that I need in this package. I have these components that I need in this package, and I just need this other small package to get dialog to go.
Those files are not bundled, right?
So the files are, some of them are bundled. So dialog and maybe something that's only used with dialog will be bundled together. But say they use some core utility function, like those things will be in a separate package. I'm not answering your question.
My real question is, do you resolve those dependencies? Say, okay, this thing are more common. Let's bundle this together.
Yeah.
Or you have a script that do all the thing for you.
Right. So there are a couple steps. First, Haste. You have you provide a resource and you require resources. So what that tries to guarantee is when you require foo, you will have foo and everything it requires, right? So at push time, when we're getting ready to update the site, or in your local dev environment, you run a script to analyze resources that will look at all the files and analyze the dependencies and make the dependency tree. So then we have another process so in our PHP, various files will say, hey, I need resource foo. Hey, I need resource bar. Every day, there's some sampling there that's logging for the home page which resources it required. And then it will try to generate a set of packages based on that data to produce an optimal layout of packages for the site. So it might say, hey, the home page, we want to have a maximum of 2 packages on that. So I'll look at all the resources that are commonly requested on the home page and package those together, and then move to, okay, now the profile. Given that I have those packages already, what else do you need? Let me make a profile package. I'm oversimplifying that process, but that's basically how it works. It analyzes given the graph of dependencies and the pattern in which we use them on given pages, it comes up with what it thinks is optimal packages.
So it's something that actually you find it when you ship something to production and you analyze it. And
so to answer your question in the shortest way possible, we resolve at build time, I guess you could call it. We resolve when we push the site.
Right. And then there becomes a static list for a given release, from a resource foo to which packaged file it's actually in. And that map we can ship down to JavaScript. So when you say, hey, I want foo, it will say you need to download these 5 files. Or hopefully fewer than that.
Last one.
Last one? Last question. I hope it's good. No pressure.
Actually, I'm going to cheat and ask a couple.
I hope the answer is good.
So I've been using this tool called Juicer. I don't know if you've heard of it, but it seems similar to Haste in terms of dependency resolution in JavaScript files. I wonder if you guys had any inspiration or you guys, or it came along separately afterwards. And my second question is, how do you guys do front-end A/B testing, and how do you deliver different JavaScript files?
So in terms of the first question, Juicer, I actually haven't heard of it. I'd like to check it out. But Haste has been around for a very long time. I think it predates most other packaging systems, and I think it was like way ahead of its time. We were in need of a solution, and somebody that worked here, this guy Evan wrote the first version of it out of straight need. We had tons and tons of script tags, and it was just very unwieldy. So Haste has been around for, don't quote me, but I want to say at least 2 or 3 years. It's been, certainly more than 2 years. It's probably been around for more than 3 years. 2?
2.5.
2.5. So it's been around for about 2.5 years. I think it might predate those other systems. I'm not sure. I haven't seen it, but certainly I'm interested in checking it out. And
what was the second question again?
It was on A/B testing.
Yeah, A/B testing in the JavaScript world is still a tricky thing for us. We don't do it that well. We have a great system for A/B testing kind of in our PHP layer. And you usually, if you want to test JavaScript file A versus JavaScript file B, you can do that. You just have to variably, in PHP, require one or the other, depending on which state of the A/B test you're in. But for us, it's still a bit tricky we oftentimes want to run kind of 2 versions of JavaScript or one that's slightly different. And then we kind of manually ship down kind of environment variables, we call them, to JavaScript, where we're basically just we have a global object that contains a bunch of settings that we can send things down to.
And another feature of Haste that allows us to do that more easily is we said we had the @requires and @provides. We also have an @noPackage tag. So if your file has that, it will be guaranteed to ship down as a separate script tag by itself. So it'll never be included with another file. So if we want to A/B test 2 versions of something, we would basically no-package them both and say, okay, ship these 2 pieces independently. Or if we're testing a new product, we can ship those things down and be confident that the script's not going to be included in one of our pages or one of our packages that everybody has. So apparently that was the last question.
Yep.
Yeah.
Cool. Yeah. Well, thanks for coming out, guys.
Thank you, everyone, for coming out.
Yeah.
Check out our sites and stuff.
Yeah, if you want to come up afterwards, we'll be hanging around for a little while. Thanks.
Why was that the last question? We have